Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about relative velocity for NEET and JEE exam part 2. Please see the part 1 and come to part 2. In the type 2 problem, we will discuss about the motion equation in relative velocity. How we can apply it. So, there is a first body. This body initially moves with a velocity of 1, u1, and the second body initially moves with a velocity of u2. Okay? This is the origin. So, x1 of 0 is the initial position and x2 0 is the initial position of the second body at t is equal to 0. This body got an acceleration a1 and this body got an acceleration a2. So, the velocity changed. So, the first body velocity become now v1 after t time. So, the position become x1 of t at t is equal to 0. The second body velocity is changed to v2. Okay, that is x2 of t after t time. Clear? x2 of t after t time. Okay, then now we can apply the motion equation. First, the relative velocity of the second body with respect to first body after t time is initial relative velocity of the second body with respect to first body plus the relative acceleration of the second body with respect to first body into t. Okay, then the second equation. Okay, that is the relative velocity of the second body with respect to the first body square is equal to the initial relative velocity of the second body with respect to the first body square plus 2 into the relative acceleration into relative displacement. Okay, then the third motion equation, that is a relative displacement, is equal to relative initial velocity into t half into relative acceleration into t square. Okay, these three motion equation we can apply and we can find out some solution of the problems. Okay, we will do the problem 1. A driver of a train traveling at 150 km sees on a track 100 meter in front of him a slow train traveling in the same direction at 25 km per hour. The least retardation that must be applied to faster train to avoid the collision is. That means this is the diagram you can draw. This is the fast train. This train velocity is how much? That is 100 and fast train like that I consider. So v1 is equal to 115 km per hour. Okay. After 100 meter, there is another train. There is a slow train. Okay. This is the engine of the slow train. This is the second train. Okay, this is to be moving with a velocity of 25. That is v2 is equal to 25 km per hour. Okay, so there may be chance for collision because the backside train is moving faster. With what retardation will happen to this train, then the collision we can avoid. Okay, so we can use this equation, that is this equation, that is relative velocity of the first body with respect to the second body square is equal to initial relative velocity of the first body with respect to the second body square plus 2 into relative acceleration and the relative displacement. Okay, relative displacement. Clear? Okay. What about this one? If we need to find out the retardation to avoid the collision, then this becomes 0. Okay, Clear. What about the initial relative velocity? That is, we can take it as u12 is equal to what we will get? u1 minus u2, because two trains are moving in the same direction. So 115 minus 25, that is 90 kilometer per hour. That means if you convert it to meter per second, that is 5 by 18, you can multiply this 18 and 90, you can divide it 5, you will get. So 5 into 5, 25 meter per second. This is the initial relative velocity. Okay, clear? So this is 25 plus 2 into the acceleration of the first body with respect to the second body. Okay, and the relative displacement. What is the relative displacement? We need to cover it. That is 100 meter. Okay, clear? Sorry, this is square. So from this 25 square come to this side, become, we can write like this: 0 square minus 25 square is equal to 2 into 100. That is 200 into A1. What about 25 square? That is minus 625 divided by 200. We will get, that is relative acceleration of the first body with respect to second body. That is, this you divide it, what you will get? 3.125. Okay, 3.125 you will get. That is the relative acceleration of the first body with respect to second body. That means the retardation happened to this is the negative value because there is a retardation. Type 3. Up to now we have studied that the relative velocity of an object when the body is moving in a rest plane. If a body is moving in a moving plane, what about the relative velocity? That we will see here. So, this is to be a railway track. Through this railway track, a train is moving. Okay? A train is to be moving. In this direction. The velocity of the train is Vt. Okay? There is a man is standing here. There is a person is standing here. There is another monkey. A monkey is moving in the same direction of the train with a velocity of Vm. With what velocity this monkey appear for this person? Okay. So that is the relative velocity of the monkey with respect to the person. So the relative velocity of the monkey with respect to the person is, now you see here the monkey is not in a rest plane. Monkey is moving in a train along the same direction. So the monkey velocity become velocity of the monkey plus velocity of the train minus velocity of the person. So this person will be feel that the monkey is moving with this much speed. Okay, that is Vm plus Vt. Okay, this is the velocity of the monkey with respect to person, because the person velocity is here 0. Okay, if this monkey is moving in the opposite direction, that means you look at here. If the monkey is moving in this direction, in the opposite direction of the train, with what velocity this monkey appear for this person? So that is the relative velocity of the monkey with respect to the person. Now the monkey is moving in a moving plane in the opposite direction. So the velocity of the monkey minus velocity of the train minus Vp. So now the relative velocity of the monkey with respect to the person is velocity of the monkey minus velocity of the train. Okay, this is the way we can find out the relative velocity in a moving plane. Okay, based on that we will solve a problem now. A police jeep is chasing with a velocity 45 km per hour. A thief is another jeep moving with a 155 km per hour. Police fires a bullet with a muzzle velocity of 180 meter per second. Here look at this. This is meter per second. The bullet strike the jeep with a thief with a velocity. So, what is the meaning of the question? There are two jeeps there. One is to be a police jeep and another is a thief jeep. Okay, this is the police jeep with a velocity of Vp, and another we can take it as this is the thief jeep. Okay, this is Vt. The police jeep, how much is the velocity? That is Vp is equal to 45 km per hour, and the thief jeep is moving with a velocity of how much? That is to be 155 km per hour. Okay, a police person fires a bullet. Okay, clear? Assume it as a bullet. This bullet is moving in the same direction with the Vp, velocity of the bullet. That is Vp is equal to how much? That is 190 meter per second. With what velocity this bullet will strike to this jeep? That is the relative velocity of this bullet with respect to thief jeep. So we will see that the relative velocity. Okay, the relative velocity of the bullet with respect to thief jeep. So here now you see the police person is firing in a moving jeep. So the bullet will acquire the velocity of the jeep also, because he is firing in the same direction. So velocity of the bullet plus velocity of the police jeep, okay, minus what? The velocity of the thief jeep. Okay, clear? Now what about the velocity of the bullet that we have to be take? We got it as 180 meter per second plus velocity of the police person, that is 45. Okay, minus what about the velocity of the thief, that is 155. These two are in kilometer per hour, so we can take it like this, 5 by 80. Okay, then meter per second. So 180 minus 45 minus 55, that is 110 into 5 by 80. Okay, so what you will get? This is 30.5 you will get. So 180 minus 30.5. Okay, that is the relative velocity of the bullet with respect to thief jeep is how much? 149.5. Okay, with this velocity this bullet will strike the thief jeep. Okay, clear? Type 4. Here we are discussing about the river problem, mainly the upstream and downstream problem. What is upstream? Upstream means the river flow is in the opposite direction of object flow. That means you consider if a boat is moving in this direction, the river is flowing in the opposite direction. So that time what is the velocity of the boat? That is the relative velocity of the boat with respect to river. So that time we can calculate the relative velocity is relative velocity of the boat minus the relative velocity of the river. In a downstream, what is downstream? Downstream means river flow is along the direction of boat flow. So you can see that if the boat is moving, a river also moving. So you see that the velocity of the boat will be increases, because you see the boat will get an extra velocity, extra push from the river. So that time the velocity of the boat with respect to river is velocity of the boat plus velocity of the river. Okay, this you can easily identify when if you are to be swimming in a river or some water flow. If you are swimming in the opposite direction, to cover the distance it is very difficult, because the velocity is to be decreases. If you are swimming in the same direction of the water flow, it is very easy to cover a distance. Okay, clear? So based on this we will solve some problem. The speed of a motor boat in still water is 7 meter per second and the speed of stream is 3 meter per second. what is the time taken by the boat to cover a distance of 1.6 kilometer in upstream? Okay, so what is the velocity of the motor boat? Boat is in the still water, the velocity is 7 meter per second. Okay, the river velocity is 3 meter per second. What we need to find out? 1.6 kilometer. How much time will take a boat to cover? So we know a formula: velocity is equal to distance divided by time. Distance divided by time. Okay, here the boat is moving in the which direction? It is in the upstream. That means we have to consider the boat velocity with respect to river. So from this you can get the time. What about the time? Time is equal to distance divided by velocity. Time is equal to distance divided by velocity of the boat with respect to river. What about the velocity of the boat with respect to river? In the upstream, the velocity is velocity of the boat minus velocity of the river. That is 7 minus 3. So you will get it as 4. So what about the time? Time is equal to distance is how much? 1.6 kilometer. So what you will get? 1.6 into 1000 you will get. Okay, divided by 4. That is 1620 divided by 4. How much time it will be get? You will divide with the 16, you will get as 4 here. So 400 seconds. Okay, time is to be 400 seconds. Okay, this is about type 4.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.